Hi, welcome to Cloud Cover. That's Steve.
And that's Ryan.
Hey, we got a show this week. I will say it's great, but it will be short. Steve, what are we doing?
We think it'll be short. We are going to respond to what someone actually asked us about on Twitter, which is WCF services in Windows Azure. And we're going to talk about how you make public WCF services and how you make internal ones that are just for your application to use. So if you love WCF, and we know you do, this is the show for you.
Wow.
But before that, we got to talk about some news.
Yeah. What's the tip of the week going to be?
It's going to be about WCF in the cloud. It's related.
All right. So, news this week. Let's start with our old standby. These guys are great. The SQL Azure team, they've been very, very busy.
They're
in
on a
fact,
roll.
just like the Windows Azure Storage team.
That's
in
right.
Fuego. They've been posting out regularly little tips and tidbits. This one's a great one, how to export your data from SQL Azure. So they walk you through the import-export wizard. This is the easy way to do it. There are also other methods, of course, which you can, for instance, use BCP, generate scripts. You can do all sorts of different ways of doing it. But they have highlighted some of the, or one of the easiest ways to do it here in this blog post. So
and they link back actually from that blog post to a blog post about just how to connect up using the R2, what is it, 2008 R2 version?
Yep. SQL Server Management Studio.
2008 R2.
SSMS.
2008 R2.
Yeah. We should just get a longer name for that.
We should.
All right.
Moving right along, I think this one's also from the SQL Azure team. We have vertical partitioning in SQL Azure Part 1.
Vertical.
So I don't know what Part 2 is going to bring, but Part 1 is all about... so vertical partitioning is, I'm going to take some set of columns and put them in one place, and some set of columns and put them in another place, as opposed to horizontal partitioning, which we've been talking about a lot, especially in the context of Windows Azure tables, which is I'm going to put some of my rows here and some of my rows there. This is the other thing. This is some columns in one place, some columns in another place. So they basically go through here and say, how can you do this? What are the sort of gotchas with this approach? And then how do you use link to just sort of join the stuff together? It's actually pretty awesome when you get to the end and just see the link query and see that, wow, this is not actually a big deal.
Yeah,
you could totally do this. So this is one of the ways that you can do sort of scale out on SQL Azure. One kind of partitioning you can do is vertical. That's what this thing is about. And presumably, the title said Part 1, so I'm going to guess that there are going to be follow-ups to this.
There's at least one more.
I suspect so, although I think it would be awesome if they just stopped here. They're like Part 1 of 1.
Just kidding.
Yeah, exactly. This is stretching the word news a little bit, so I slipped this one in this week because I didn't see it before, but it's actually been up there. This is on Code Project, and this has actually been there since what? May 19th, is that? No, May 19th is the update date. Wait, scroll up one little bit there. Posted April 21st. So that's stretching news a bit, but if you haven't seen it, like I didn't, then it's new to you. And basically, this takes that thumbnail sample that ships with the SDK samples.
That's in production around the world.
And that's true. That's powering some of the largest photo sharing websites today.
I think Flickr uses this.
I'm pretty sure.
Yep.
I didn't hear anything about that, but I'm just guessing that's what they would do. And the thumbnails sample uses blobs and queues, doesn't use tables. Well, guess what? Over here on this this Code Project page, you see how to add tables to it and basically store metadata about the different photos in tables. So it's sort of how to merge table storage and blob storage with references between them, things like that.
I bet you were not aware is within the sample as well, you can actually get 60 free controls.
Yes, that's true. They complete with ads on the side.
No, this looks very interesting. I like the fact that they link to a few blog posts in here in the past, and they also have some code in here. Yep. Easy cut and paste or download. So it's great.
It's very cool. Very, sort of introductory about how to do this, but it's a real practical question of like, if I have structured data and unstructured blobs, how do I use storage effectively with both kinds of things? So so cool. Check that one out. This is actually a video that's up on Channel 9 with one of our customers, Data Castle, who's doing data protection in the cloud. So you got your laptop with a bunch of sensitive stuff on it. What happens if you lose your laptop or whatever? So they're doing kind of backup, kind of encryption, but also also sort of web management of that stuff, and you get to sort of choose things in this website and whatever. This is basically an interview plus demo of the Data Castle stuff, and they talk about kind of how they used Windows Azure, what benefits they got from there. So for those who just want kind of another data point on who's using the cloud and how, these guys are doing some interesting things.
That does sound cool. Right. At home with Windows Azure. You know, I've heard if you give them 2 hours, they will actually hand to you the cloud.
Yep. It's hard to hold on to after they hand it to you because it's all sort of water molecules, but they will give it to you. This thing is cool. The sort of advertising point for it is really if you go sign up and do this 2-hour training, basically, it's a sort of 2-hour course. Right. At the end of that, you get a Windows Azure account that you can use for the next 2 weeks as sort of a trial account, and you don't have to sign up to do anything after that. So if you just want to kick the tires for a couple weeks, this is a way to get a free account and get some training right off the bat about how to use it. Yep. What they do teach you to do, and the reason this is at home, is they teach you to deploy this folding at home application from Stanford that does protein folding, and they've got a number of ways that sort of everyone can contribute to science by doing this protein folding simulation on their machines. This is one way you can go deploy it to Windows Azure, and you get some free hosting, so that's a decent thing to do with it, is just go deploy this thing. So it's kind of cool. They're doing this like every week or so. Actually, if you scroll down, Ryan, they've got the schedule even beyond that.
Yeah, it is.
And they're filling up, as you see. So the next available date at the time we're recording this is June 1st. And I wouldn't be surprised if that one fills up quickly, too. They have a maximum of 100 participants each week that they do this. So if you think you might be interested in this, go sign up now and get in there. Looks pretty cool.
Well, yeah, the actual problem that they're solving, too, is pretty ideal for a cloud platform, or kind of a scale out
because it's really parallelizable.
Exactly.
You got all these little simulations to do, and you need to do them. It's a cool thing.
That's great, man.
And it's for science. You know, if you're trying to justify playing with Windows Azure and you couldn't think of a reason, well, now look, you're going to cure diseases and stuff.
Or you could thumbnail everything.
Yeah, one or the other. Both are really good
from the SDK.
Absolutely.
All right. So the topic this week.
Yes.
The topic this week is how to host WCF services in Windows Azure. And this comes up a lot. We have this WCF role, or template at least, in our Visual Studio SDK and tools. And a lot of folks want to take it and they want to host both public services, meaning like I will have an SVC endpoint or something like that that's directly accessible from the cloud.
And it doesn't have to be public in that anyone could use it, but exposed to the internet.
Exposed to the internet. Right. And then we have other folks who want to actually, as part of, like they do on premises, use a business layer or something like that, and you have a web front end talking to a business layer. So it's probably worth going into a little bit of the details, the architectural details, and talk about how this is actually implemented.
Yep. So
I'm going to draw your prototypical kind of logical architecture diagram that you're probably pretty well familiar with. At one point we have a web front end, we'll call this W. We have a business layer, and we have a data layer. Now, between these, we have obviously different ways of communication. On premises, you could use something like this could be within the same physical confine, and then it's just on the machine, it's in process. You could use remoting. You could have this exposed as a WCF service. You could do all sorts of things. When we take this out of the on-premises world and we want to replicate something like this in Windows Azure, what we want to do is we want to expose this in a way that is available between roles or inter-role and not to the general public. So if you recall from the last time Steve drew his architecture diagram, we have a load balancer, and all inputs that the world can send to you have to go through this load balancer. So there's a public virtual IP or a VIP address and some ports associated with that. And when you send it to the load balancer, it gets routed to whatever you have that's listening to it, okay? And at this point, you say to yourself, all right, so if I wanted to expose a WCF service, I obviously have two ways of doing this. One is I declare an input endpoint, hook it up to the load balancer, and all my requests will come in, and let's say this is hosting my WCF service right here. it'll come in and it'll get routed to it. Now this gets a little dicey when you say, well, what if the consumer of this is always the web tier? It's never going to be a client out here directly. It's not going to consume this WCF service. How do we do that? What you want to have happen is you want this internal endpoint to be exposed here only between, obviously, these roles, and you want to disinvolve this load balancer. So the way this is done is we have something called an internal endpoint, or is it intra endpoint? I always get this.
Internal.
Internal
You got it
endpoint.
right.
I got it right. All right.
Don't second guess yourself like that, Ryan. Go with your gut.
You gotta go with the flow here sometimes. So we call this an input endpoint, and we call these internal endpoints. So just for nomenclature, if anyone ever says that to you, a little bit of a misnomer in some ways because we call it inter-role communication when really it's inter-instance communication, because you can also talk to the same instance or any role to role or role to instance combination. So to do this, what we're going to show today, we're going to show two different things. One is we're going to show how to set up these input endpoints so that, these internal endpoints such that only this web role can talk to this business layer. And then we will also show how to host a WCF service, perhaps we have it hosted here, that is actually you do want to expose over the load balancer. And because it's on a load balancer, there's slightly different behavior that you might not be used to if you did this on the on-premises world. So with that, let's jump into some code.
Let's do it.
I am going to start with the simplest thing I could possibly do, which is a new project. I'm just going to create a new one. And I am going to call this one, let's call it Cloud WCF. Now, you could do this, you could follow along at home. This is going to be the world's simplest WCF service. What I want to do here is I will add the template that we have for hosting a WCF service, and I'm also going to add that worker role because I'm going to replicate this architecture we talked about. Now, I will take the time right now to actually rename this web host.
So one thing that might be interesting is
And
you know,
worker host.
people know their web roles and their worker roles.
Mm-hmm.
I know explicitly that this one's a worker role that you're looking at right now. What is the WCF service role? It says web role.
Mm-hmm.
So it's a web role, which means HTTP and HTTPS only. And okay. You could also do this in a worker role, right?
Absolutely. Absolutely. So I'm showing you, most people who have like an on-premise services today, they use IIS as a host if you're going to publicly expose it a lot of times. Not always, but when you do that, you obviously get some benefits that IIS has.
Right.
Right. So a common thing to do is to go with the SVC model, and then if you needed to scale that out even on premises, you do some clustering, you do some load balancing there. So it's pretty common.
So yeah, the question I was getting at is when should you choose to use a web role to host your WCF, or when should you choose a worker role? And I think you answered it, which is when you want IIS and you want a .svc file, or you want that IIS kind of activation, right? Then you use a web role. If you don't want that, if you're going to run your own host, your own service host, then you could use a worker role to do that.
Yeah, absolutely. And you'll have
cool.
to, if you don't use the web host, obviously you have to kind of manage yourself the lifetime of that service host and how those behaviors and activation as well. So I've just renamed these, and this will be for my reference later when I need to refer to them. Once we create this solution, you'll see that this is just out of the box, very, very simple. The worker role is exactly how you would see it today. There's nothing different in here, so you have your run on start, etc. And they've created this stub class that's an implementation of iService1 in the web host, just as a kind of a way for us to get a quick view of what a service would look like if we hit F5. So the first thing I want to do is actually go create the WCF service. And as I said, I'm going to create kind of the world's simplest service here. So I'm going to go down to the worker host and do a couple things. Since I'm creating a WCF service, it makes sense to probably reference the system.service model. And that's a good thing to start with. You'll notice that you need that, actually, if you're going to use WCF.
You don't see that.
Things don't work.
It just won't work.
Right? So I'm going to add a new class here. Now let's call it Echo Service. This is going to be the world's most complicated service. Public echo service and public string.
I can guess where this is going already.
Nick.
As soon as you called it echo service.
Well, it's almost an echo service. It's because we do change it. We're going to return. You said, right? Plus message.
That would be a creepy echo if you went into some cavern somewhere and you said hello, and it came back and said you said hello.
Yeah, that would freak me out as well. So we're going to implement an I echo service interface, right?
Which doesn't exist yet.
But it will.
Ooh.
Look at that. It now exists, and I'm going to change this to a public interface. And again, we're going to say string echo string message. And at this point, we need to add a few decorations to let WCF know that this is the contract that we're going to be working with. So we want to add service contract. And add operation contract.
So far, this is exactly what I would do if I were hosting a WCF service on IS anywhere.
Yep, nothing's changed here.
Okay.
Really, at all. Now, we have the service and we have the contract at this point, so we're kind of set. Now we just need to host it. At this point, I just go to the worker role. And it's best if you probably start your host in the on-start. As we've explained in other episodes, this is the time where you kind of get to prep stuff and before you're hooked up to the load balancer. So, you know, you do want to actually get anything you want running in the on-start up front. So we'll go ahead and do that.
But once you return true from on-start, traffic's going to come to you, and if you haven't started that WCF listener,
yep. So I'm going to start a WCF host. And the only thing that I'm going to do in here is I'm going to first get rid of this line, obviously, and create the host. So our host is new service host. And we need to give it the type. In this case, we're going to do the type of echo service. And then we need to give it this base address. So we'll do new URI, base address. Now, what is this base address, you might find yourself asking? Well, let's define it. This is going to be, we'll use the net TCP service. So what I'll do here is I'm going to set up a net TCP connection format. And the way I'll do that is I'll put in the format like this. And then I will fill in information from our role environment, the current role instance, and I want to grab that instant endpoint, and I need to grab the name of an internal endpoint, and I'll just declare one here, echo service. I want to grab the IP endpoint. So if you look at this, what I've done is I'm asking the role environment to give me the IP endpoint for some port that I've declared. Now you say to yourself, well, you haven't declared any port yet, and you're correct. I'm going to do that by going up to the endpoints, adding an endpoint on the worker host and calling it echo service, and changing it from endpoint to internal, and then I have done it. All right.
That's it.
Now,
so that's the only thing that we've had to do that's Windows Azure specific, because normally you would go, well, I'm just going to open port 12345, so I'm just going to hard code some endpoint in here. The gotcha here with Windows Azure is when you're doing an internal endpoint, you don't know what the IP address is because it's going to be on some random server sort of as a part of the role, and you don't know what the port is because we actually assign those ports at random. It may not be random, but to you it's random. You don't know what's going to happen.
You shouldn't count on the port. Let's
exactly.
put it that way.
And so you're going to get some port assigned to you, and you better listen on that one. That's the only one that's open. You don't have permission to just go open up a new one because you're not an admin on the box. And so, important to do that part. And probably conceptually the only thing that trips people up on this.
Right. One of the last things that we have to do, of course, is add that service endpoint. And really what we want here is say, well, we're going to be doing that type of IEcho service. We need to give it a binding. In this case, we've already declared we're going to use NetTCP, so let's use the NetTCP binding. Let's do a new one. How about that? And then we have a security mode in here, and we're going to set that to none. Within instances or within roles, you're kind of on your own virtual LAN segment, so you really don't have to worry about some other outsider or compute system outside of your control being able to snoop on that traffic. Additionally, adding some of the other security modes, while it's possible, it takes a little bit more work to set up how that authentication is going to
And the
actually
default
occur.
one you'll get is Windows authentication, which
Right.
isn't going to work because you don't have, there's no Active Directory, it's not the same user on these different machines, so it's not going to work. So unless you explicitly set something, you're going to see an error. You could use, certificates are probably the next best thing to do if you really want to get to that level. You could upload certificates with the application, use the same certificate on the client and on the server, and things would work for you. But as Ryan said, just the fact that the packet filtering that we do and things like that mean you're isolated on the network, and so it's kind of like running in a closed room that's not connected to the outside world. Why do you need that kind of message level security between those different endpoints?
Yep, indeed. So all I've done at this point is really declare, add that service endpoint, and the last thing to do is to just open the host. Now, in practice, what I would typically recommend folks to do is actually put maybe a retry loop on this and catch if the host faults. Because it's possible sometimes you can get a behavior where something doesn't start up in time or the service isn't ready or whatever it is. So you can actually do a retry here and kind of just a countdown every time that if this host were to fault for some reason, just give it another shot and try to
Although if you leave it as is, it's probably just going to result in an exception getting raised from your on start, which means Windows Azure is just going to recycle the thing. And so you'll get a retry indefinitely every so often, however long it takes to sort of restart the thing, which might be okay. But yeah, what Ryan's suggesting is probably a better way to catch the difference between sort of spurious, it just doesn't connect fast enough, versus no, there's something wrong with my configuration, or I'm getting the wrong endpoint, and there's a real problem that I have to debug, where you don't just want it kind of cycling forever.
So this is it. I mean, the work that I've done here is I've created the service. I've now opened a host and started listening on this endpoint. That's it. We're done at this point. The only thing to do is to write a client that actually consumes it. And I'm going to do that over here at this web host. Now, what I'll do actually is I'm going to add a new item, and I will do default ASPX, because that way, when the site starts up, it'll be real easy. And I'm going to do the opposite of what Steve does, which is I'm going to use the toolbox and not.
You're going to drag, drop stuff. And
I'm going to drag and drop like a fiend.
Right, and if people realize that stuff is this easy, they're not going to come to us for help anymore. You can't let the cat out of the bag.
Yeah, so I'm dropping the standard text box, a button, and let's drop a label in place as well. This will capture our message. I might even go down here, though, and change the label so that it doesn't say label. It'll just say nothing. How's that sound?
That's some advanced customization you're doing there.
I know, it's very, very. This is beyond Steve's design skills.
I couldn't do this.
But I've been working on this for years. Don't call me Mr. Default ASPX for nothing.
Yeah.
All right,
So is default your middle name?
yeah. Well, yeah, basically.
ASPX.
Ryan
Default ASPX.
Now, one of the other things I need to do here is I want to add an existing item. In this case, I need to reference the contract that we have so this service knows what it's going to be consuming. So in this case, I'll do existing item. I'm going to go out to that worker host, grab that iEcho service. I'm actually going to add it as a link because I'm kind of lazy like that.
What does that do?
Well, instead of copying the file, so you have two files that get versioned differently, it means if I change the file in the worker host project, then it automatically is updated.
Okay.
It's like a
So it
like
adds
a
the
sim
dependency
link. Yeah.
things.
So I don't have to worry about.
That's cool. I'm learning things.
Yeah.
Not about Windows Azure right now, but about Visual Studio and .NET.
That's good to know. So we're going to call this. I'm going to spin up a factory, so a new channel factory. And it will be the worker role or worker host iEcho service. And the one thing that it wants to know in here is actually what kind of binding it's going to be using. So we will say new net TCP binding. And again, we'll do that security mode, none. And now I have a factory. I'm going to create the channel. And at this point, the things that it needs to know is an endpoint address, or so where is this service actually located? So let's do that by getting a random endpoint.
This makes it sound like you're choosing a complete random. I'll just make IP address, just a random address, and
basically,
if my worker role isn't listening there, I'll just try another random one till I get it.
It's similar to that. So I'm going to create a stub out a method here to return a random endpoint, and you'll see why here in a minute. Because one of the things that we've covered before, and maybe it bears reiterating, is when you declare an internal endpoint, these are non-load balance. Remember, the picture didn't have a load balancer in here, so if you want to get a service, you have to know where you're going. Now, if I had a whole bank of worker roles in this worker host, I wouldn't want to pick one of them and send all my requests to it. Right. I'd like to load balance that, and this is kind of my poor man's method of load balancing.
And you don't have to load balance. If for example, you're doing, memcache or something, and you had, that guy's the one who has the results that I'm looking for. You can go ahead and talk directly to that specific one, and that's why the API works the way it does, which you'll see in a moment.
All right, so I'm going to set the label text equal to the channel echo, and I think it's text box 1. Yeah, there it is, text box 1. Text.
That's what you get for drag drop. Everything's called like text box 1,
I should call
label
it
1.
Smarksy box 1.
Smarksy box.
All right, so now comes the interesting part. All of this is just standard WCF.
Yep.
I've done absolutely nothing that is required to be in.
Very similar to the other side of this. The hosting side in the worker role is the same thing. Everything was pretty much the same except that address.
Yep.
And
so,
I think it's cool that it's the same way on the other side.
So here's how you do it. We're gonna grab all the endpoints, and we do this by doing the role environment again. And let's get a reference to that. Role environment roles, and we want to grab the worker role because that's where our service is located.
Yeah.
Go figure. We'll grab the instances, and let's select out of that.
Actually, isn't it called worker host?
You're right. It is worker host. Good catch, Steve.
Thank you. This is a string, and you have to get it right. So this is one of those places where you do want to double check.
Magic string.
It's a place where you could beat your head against a wall for a while before you figured out what the problem was.
So what we want to do is project out of all of our collection of instances all of the instance endpoints that implement, it was echo service. You want to get this right too, otherwise you're not going to get much.
Exactly.
And then we want to grab the IP endpoints for that. Excuse me. We'll just grab that, and then I'll do it to array. How's that sound? So I'm going to grab now. I've grabbed all of my instance endpoints that actually are implementing that echo service for the role worker host.
Okay.
Okay. Now what I want to do at this point is I need to return one of these particular instances that I pick. Okay. So let's get something random. Lead time now, millisecond. Let's do that, and then return a new endpoint.
I think you just leave it blank. I think you do new random paren, and it does use the clock or something.
Really? I didn't know that.
I think so.
I'm learning things here too.
I don't know. Anyway.
All right. Let's do this again. So string format, net, TCP, MAC. We know we were going to fill in that host name, and then we know it's the echo service.
Yep.
And what I want to do here is grab the endpoints, and I will grab a random one, so r dot next, and the max that I want to grab is obviously endpoints dot count -1, and then I want the IP endpoint for that.
Right. And close the string.format. Yep.
And close that. What am I not closing? Endpoints count. Oh, here we go. Next. Missed that one. There you go.
There you go. That looks about right to me.
String format. Is that right? I think I'm missing something still.
Uh-oh.
String.
What did you do?
I need one more. It's hard when
Right,
the
'cause it's
screen is
new,
the screen is
right.
so big. There we go.
Right.
Okay, the screen is so big now for for the show, and now I can't see the whole thing. All right, so now I have this random endpoint, and if I run this service, and if I haven't screwed up completely, this will actually work.
So just to recap, because I love how simple it is, right? All you did was you said, all right, let's create a connection to that thing. Instead of a hard-coded service URL that you know, because it's on server number 3 or whatever, you said, grab a random endpoint from all those instances of that role. So it said, all the worker role instances,
Yep.
give me your endpoint, chose one at random,
Yep.
filled in the address, and that's the one we're going to use. So basically our own kind of random load balancing
Exactly.
between the roles. I think that's pretty cool.
Hi, Steve. And if that works, I have to click the button. If that works, I'll see you said hi, Steve.
Wow.
Wow, indeed.
Brilliant.
Bravo.
I'm
Isn't
going
that
to give
great?
a round of applause for that.
So
Bob, could you just put in a round of applause? Could you retroactively, what I'm saying now is that we just heard a round of applause for Ryan.
So what we have here is, and we've demonstrated this, is we now have a way to host our business layer using internal endpoints. And really the only gotcha was dynamically getting that endpoint
Yeah.
at runtime. And then the other gotcha that you have is, once you dynamically get that endpoint, correctly setting up the channel factories and that kind of stuff. And it's really
Yeah.
pretty simple.
Not too bad.
Okay, so you'll notice in the solution that I have, I also have this service 1, right? What if I wanted to host this one? Let's walk through some of the common pitfalls here. So
this is I want to expose a service to the internet.
I'm going to expose what was already built out for me because I'm really lazy and I don't want to create another WCF service.
All right.
Yes.
That's what I like to hear.
All right, so we'll go back to our Internet Explorer and let's pull up that service and look at the metadata. And when I do that, you will see the following, which is this nice MEX endpoint page. It'll kind of give you some data, and then you'll go, oh, let's try to look at the WSDL. You'll run this, and you'll go, oh, bad request.
That looks awfully suspicious.
So your first thought is, hey, you know what? This looks wrong. That's 5100. Where the heck is that coming from? Well, I'm way more clever than this dumb thing, so I'm going to just change it to localhost port 81. And do that, and then you'll be, haha, I'm so smart now.
Yep.
And then
Done. Let's
yeah,
just
I'm
use
done.
that.
I'll ship it. I'll ship this WSDL to someone.
Works perfectly.
And then you will find yourself crying later.
But no.
No,
You would be
gotcha.
wrong if you did that.
Because if you look down here, you'll see that, aha, we still have
It's
that
all over here.
in
Yep.
the service. So this is actually a problem. It's because we're behind a load balancer. What you have at the service head is it's reflecting what it's bound to, which is obviously port 5100. That's
Right.
what we asked for, that's what we set, that kind of thing. So you're going to get this behavior that you don't want. You want the external facing address and you want the external facing port, which is obviously different. So to fix that, how do we do that, Steve?
Well, before we get to that, it's probably a good time to transition to the tip of the week, which is everyone's favorite time in the show.
All three of them.
All 3 people, Samantha J. Billinger from Montana,
Yep.
was it? And
She's the Smarxophile.
her 2 friends
Yeah.
are always looking forward to the tip of the week. I didn't think of anything. I've been sitting here the whole time paying attention to what you're doing. I didn't actually think of something to ask our editor, Bob, for. And so I'm wondering if we could just ask Bob to look into the depths of his insane mind and show us what comes out of that to introduce the tip of the week.
All right.
Let's just put it all on Bob.
Bob, I think he was a child of the 60s, and there could be an LSD theme to this one. Are you sure you want to
There
go
we have it. No, I think that's perfect. I think that's exactly what we need. And so, with that, here is your tip of the week.
All right. Tip of the week this week.
That was trippy.
How to get
I'm assuming.
the service endpoint up and running.
Yes.
Now,
So basically, the tip is how to fix that. Right?
We explain the issue, which is you're a load balance address.
Yep.
So therefore, you're actually you generate the wrong metadata essentially.
Because WCF doesn't know, right? You're bound to port 5100 in the case of running on the dev fabric here on Ryan's machine, and how could WCF do anything different?
Exactly.
Because it doesn't know. It knows what it bound to.
Right.
And there's an answer for it, though.
And there is an answer. So the answer, of course, is if you take a look at the service model that you have, you see how it's been declared in here, and you see some behaviors. What you don't see is a new behavior introduced as part of a QFE. QFE is kind of like a hot fix that we have.
Quick fix engineering.
Exactly. And if you go to code.msdn.microsoft.com/WCF Azure, and you hit the known issues page, you will find a link to this for hosting WCF services. And one of the things it'll have is a link to that QFE. Well, I've already installed the QFE because showing it on the show would be very boring.
Exactly.
What you got to do, though, is you've got to grab this little snippet right here, this use request headers for metadata address. Just copy it and head back to Visual Studio. And I will fix a couple things in here. I'm going to get rid of this because I can. And I'm going to go down to the service metadata, service debug, and I'm going to drop this in here. And you want to match up the ports that you're running on locally if you're running this in the dev fabric. So I happen to be on port 81 because I have IIS bound on port 80 already.
What happens if you don't?
You'll get port 80. If you don't have IIS bound already, you'll get port 80.
No, but I mean, what if you don't set these defaults? What if you don't put 81 in here, and what will it do?
It'll put the wrong port.
Really?
Yeah. It puts whatever port's here, or that's what I've noticed in practice.
Okay. All right. So
So
then you do want to double check those.
And for you, it's pretty easy.
But in the
'cause
cloud, I'm not going to be on port 81, right?
Correct. You're going to
So-
set this to whatever you declared in your service definition. Because you define up front what port you're on, and in this case, you're on port 80 most of the time. Since I'm showing this in the dev fabric, I'm leaving it at port 81 because that's actually the port I'm on.
Okay, makes
sense.
sense.
So this simple change, and I'll redeploy just a...
What's with the squiggly line, though?
Well, it looks like what they haven't done is updated the XML schema, for this particular
So
thing.
you'll see that when you do this. It'll just say, hey, that doesn't look like a valid thing, but it'll compile and run fine. I mean, that's not...
Absolutely.
You can actually ignore that thing because you know better.
And bam, the first thing you notice is it no longer says that Dunry 7 stuff. It says 127.0.0.1. No place like home.
And what if you changed your URL to localhost? Could we try that? If you just did localhost:81? Because I think I know what's going to happen. But I want to make sure.
I love experimenting.
Yeah, that's what we do on the show.
Look,
it says localhost. And that's because the way this thing works is it looks at the actual host that's coming in on the HTTP request. So no matter how many load balancers, proxies, whatever you go through, that host header remains the same the whole way through. So that's what WCF is now looking at because of that new behavior. So if you use localhost or you use 127.0.0.1, or when you're in the cloud, if you used myapp.cloudapp.net or you used myapp.smarks.com, which is my own custom domain for it, it will still work the whole time. It'll show the right URL, it'll do the right thing, which is fantastic and what you want.
And it will also correctly show the metadata.
And all that stuff is right too.
Yep. And now,
Awesome.
if you were to actually run or test this service, which I believe you can do pretty quickly if you run the WCF test client, and we will just go ahead and add that. Look at that, I already have it up and running.
Look at that. You're so prepared, Ryan.
I wonder if I've done this before.
Yeah, it's
This
almost
is the
as
first
though
time
you
I've
rehearsed
ever
it.
seen this. And we do a little get data action. There you go. You
And it
entered
works.
0. It's kind of like my Echo
It's
service.
pretty much the Echo service.
I was inspired.
It says entered instead of said.
And that's it.
Isn't there one more thing we wanted to talk about that we don't really understand, but we wanted to talk about anyway?
Well,
We were talking about this before the show, and Ryan said, like, well, we shouldn't let people know that we don't know what we're doing. But what I think is, look, people have watched the show, they've seen us do a lot of stuff. Everyone should be confident by now in our lack of understanding.
I think my exact words was, I don't really want to explain it because I'm not exactly sure everything it does.
Yeah, and I'm not either, but let's talk about it anyway because I think it might be important, but I'm not really sure. So if you look at this page...
Let's look at this, and really the issue is the address filter mismatch, all right?
Yes.
I've
seen this before, but I don't fully understand when I'll see that and when I need to add this attribute. And that's kind of where Ryan and I are a bit lost now, and I'm sure someone's going to clue us in after this goes live.
We could have someone in the comments tell us, but
sure.
I imagine you have to have a black belt in WCF to understand this. But
Maybe.
It sounds like what happens is if you have a address that's shown on here, it might not match what it thinks it's at, and you'll get this tossed out kind of. Hey, you're filtering. My default behavior is to only accept addresses that match my host name.
Right.
So
And so I think it comes up when you've got in your web config, you have there's an address in there or whatever, right?
So the easy thing to do here is actually just to go ahead and copy paste this service behavior. And over in Visual Studio, what we need to do is go find that service, which is right here.
No, it's actually it's the other one, right? It's iService. It's Service 1.
Oh yeah, well, we were
Not
talking about
iService,
we're talking
Service
about the Echo. You're right.
Right, because this only applies to the internet-facing ones. Because on those internal ones,
it wouldn't hurt.
It's
on
a
the other
specific.
one either,
you could put it on there, but you won't run into this problem. I'm fairly confident. As little as I understand this issue, I'm fairly confident of that one. But yeah, I believe you can just stick that on there, and that's all you have to do.
Just stick it anywhere. And you hit compile if it doesn't work. Don't call Steve.
Yeah.
Okay.
Fair enough. Put it any line in any file. It'll work.
Add it to every class in your project.
Why not?
You're fine.
Just address filter on everything.
All right.
On your default ASPX page.
And the last caveat here is if this opens up a huge gaping security hole, again, I had nothing to do with this, folks.
I didn't either. Neither of us, actually. This thing just put itself into the show.
And anybody who actually watches us and also uses the Twitters, can they tell us what we did, what we actually did, what the implications of this are? At Cloud Cover Show, please.
Right. And if this doesn't work, just contact Samantha J. Billinger
in Montana.
With that,
I think that's it.
I think that's about it. If you do want to talk to us about anything, but especially about what we just did that we don't understand, tell us on at Cloud Cover Show on the Twitters. And
had like 5 of
this
them.
episode can't hurt.
Nope.
Can only help. This episode was inspired by one of our many tweeters.
The tweeterers.
Tweeterers.
Yep.
So you could be one of those people, and then you could feel really cool, and you go, "Hey, I made that show happen."
You did.
So
it's all because of you.
Yeah. Until next week.
Yep.
Bye.
Bye.